Welcome to this lecture as part of this course on basic construction materials. In this module, we will be looking at metals. It's the third lecture in metals module, and we will be talking about coated reinforcement and pre-stressing steel, and also some test methods as part of this this lecture. So, this is the outline. In the previous outline of this module on metals, in the previous lecture we talked about we talked about iron products, and also looked at steel reinforcement, which are uncoated reinforcement. Today we are going to talk about coated reinforcement, pre-stressing steels, and test methods and specifications. So, also we will have another lecture on structural steel by Professor Arul Jayachandran. Now, these are some of the books which we use for this course development, and definitely also we use a lot of information from the internet to make the course more informative, more easy for you to understand for demonstration purposes, etc. So, the type of reinforcement which are uncoated reinforcement, these are the five major types of uncoated reinforcement. We already talked about this in the previous lecture. Today we are going to talk about 6, 7, 8 and 9. That is 6, 7 and 8, they are coated reinforcement, that is fusion bonded epoxy coated rebars, typically which comes in like green color rebars, the rebars with green color coating, and then cement polymer composite coated rebars or CPC coated steel rebars, and then galvanized steel rebars, and then a pre-stressing strand which is of much higher strength as compared to typical rebars, and then applications are also very different. We also have today in our industry a lot of these fiber reinforced polymer or FRP rebars, which are essentially plastic rebars. We will not cover that in this particular module, but I just thought of just telling you that there is a material like that or a product like that which is available as a replacement for steel reinforcement. So, it is essentially plastic, so it is lightweight, it is very easy to construct with, essentially a composite material. Okay. Now, fusion bonded epoxy coated rebar, FBE, fusion bonded epoxy coated. So, let us look at what are the protection mechanisms or why we actually use this or this kind of rebar. So, as you can see on the picture, there is a green color coating which is made of epoxy. So, you have this green color coating on the reinforcement. You can see the cross section at the right side, bottom right, where this is the concrete, and so you have the steel reinforcement and then a green color epoxy coating which is covered by the concrete. So, this is the system we are talking about when you put this type of rebar in the concrete. Now, what the protection mechanism is, this paint or epoxy coating, it is not painting, it is coating. Okay. There is a little difference between painting and coating. So, this coating actually eliminates direct physical contact between the metal, the steel, and the electrolyte, which is the concrete. So, there is no direct connection between the supposed to be there is no connection between the steel and the concrete if it is a very good quality epoxy coating. Then it also reduces the ability or the potential difference, what is the driving force for the corrosion reaction to happen. So, there is a protection. So, mechanical barrier is actually provided, and because of this you also have a reduction in the oxygen supply for the steel at the steel surface, because you know that very well that oxygen and moisture are essential elements for or essential for the corrosion reactions to happen. Like in the cathodic reaction you have both oxygen and moisture. So, if you can stop either one of them, you cannot have corrosion to happen. So, this epoxy coating provides a physical barrier, and it provides or reduces the driving potential, and also it provides the barrier against the oxygen. Okay. So, at the steel surface you have really a lot of so you don't have any oxygen or moisture if you have a good quality epoxy coating. Now let us see how this epoxy coated rebars, or rather fusion bonded epoxy coated rebars, are manufactured. I would request you actually not to use the word just epoxy coated rebar. We have to emphasize wherever we write about this type of reinforcement, we should write fusion bonded epoxy coated rebar, because that coating is not really good coating is not possible if you don't go for fusion bonding. Just applying coating on the steel surface doesn't really help in getting a very good contact, or it will be like painting rather than a coating. So let us see how it is manufactured. So as you see on the top left image, you can see a clean rebar is passing or is pushed into a chamber where there is a mist of epoxy, okay, and this rebar is not just clean, but it is also at a higher temperature. So you can see about 220 degrees Celsius. So you have this bars going, hot bars which goes into this chamber. So what will happen if you have a mist of epoxy? They will actually try to fuse and stick to the steel surface. So that's why we call it fusion bonded epoxy coating. So the right picture on the top right, you can see that the bars are coming out. Now they have a coating on the surface. So epoxy resin powder is ionized and attracted or fused to the steel surface by electrostatic forces. Now bottom left picture, you can see once the epoxy coated, this coating happens, still the bar is really hot. So if you don't quench or cool it down, what will happen is the epoxy will start flowing downward around the surface of the rebar. So we quench that steel so that it just gets solidified very fast and prevents the flow of the epoxy around. And then you also have to inspect these bars for holidays or damage. So what are these holidays? The holidays are basically the very small micro pinholes which could be there on the epoxy coating. So if you have these small holes which you may not be able to see with your naked eyes, so you will need other technology or tools to test these holidays, like a brushes are available to which we can use to check whether there is holiday or not. So you check all this, and then if it is all fine, you can use this bar for construction. Now problem is most often there could be holidays or pinholes, and this is a picture on the right side which you see, it's a micrograph. You can imagine this size is the size of this micrograph is only about 1 millimeter. So in 1 millimeter, that small size, you have so many of these black spots which you can see. These are all black spots through which water molecules, oxygen, etc. can penetrate through. So when you see, this is a green surface, because you look through microscope, that is why it is in a gray scale. But the point is that you can have a lot of these pinholes or holidays on the rebar surface. Okay. So when you have something like this, it's very, very difficult to prevent corrosion. And what type of corrosion? To prevent something called underfilm or crevice corrosion. Okay. You can Google on what is crevice corrosion to read further about it, but underfilm corrosion or crevice corrosion is the typical damage mechanism or corrosion mechanism which will happen in this kind of when we use this kind of bars if they are not of good quality. One example where you can find this kind of corrosion is if you go to your house or wherever, maybe a gate where steel is used and you have painting on that. Even if you do a very good painting, you will see that after few years, what will happen? You will start seeing blisters on those gate, right? The steel surface or window grill, doors, etc. You will start seeing blisters. Why these blisters are coming? Because on the paint, there are still these kind of holidays or pinholes which are present, through which oxygen and water molecules can go through. So they can actually go through all these pinholes and reach the steel inside or steel beneath, right? Once they get inside, then they get trapped, and then there is something called crevice corrosion can happen. Okay, let's not go more into detail on that, but I am trying to show you an example which you can very easily see when you look around a metal gate at your home or a window grill where you have applied paint, but you still see blisters, because there are these very fine pores available on the paint surface through which moisture and oxygen can penetrate through, and they will get trapped in between the coating or paint and the steel surface, and then it will start corroding. Okay. Now, other way of these bars getting damaged, that the pinhole is what I am talking is in the manufacturing facility itself. If the coating process is not done properly, you can have that. But now let us get the bar onto the site, and what do? You will bend this rebars. Okay, ideally speaking, you are not supposed to bend it after applying the epoxy coating. Abroad, when we will see that the bars are bent first and then they are epoxy coated, but unfortunately in our country this is not the practice, even though it is recommended in the codes, but we see a lot of places like this. As you see on the photograph, we bend the bars after they are brought to the construction sites, which is not a good idea. It should not be practiced. Okay, what will happen at this point here, wherever we use that little tool to lever to bend the rebars, what will happen is it will pinch, because epoxy is very soft material and you are using a metal tool. Like this is the metal tool, right? You have a rebar, you can see that lever arm. Okay, so that metal tool is used to bend it. So what will happen, as you see on this picture here, you can see exactly where that person actually holds this lever to bend the bars. You will have pinching. You can see here pinch, right? So this is something which need to be avoided. So we should not use any hard metal as tools for they should not be applied or using. They should not be using these hard metals as a tool for bending the rebars. So best thing is bend the rebars before you apply the epoxy coating and then bring them to the construction site. So we should not bend these rebars at construction sites. Now that's something because of cost issues and all that, people are not doing it, but actually we are really harming the rebars. And also when you expose these rebars at construction site for long period of time, what will happen is the volatile materials on the epoxy, it's essentially a chemical, right? So when it is exposed to sunlight, it will become brittle. Okay. At home also you might see, if you have, let's say plastic, any not typical plastics which you have at home, if you leave it outside for some few months, you will see that they will start becoming brittle, they will deteriorate. Okay, similar thing happens to this epoxy also, they will start becoming brittle. And now if you bend a bar which is having a brittle epoxy, it will crack. So that's what is shown in this red square rectangle there, where you have a cracked epoxy. Okay, so this also will lead to crevice or underfilm corrosion. So cracking of epoxy is not at all a good idea, whether it is due to mechanical damage or sunlight or whatever be the way, we should not have this, we should not allow this epoxy to crack. Here is another example where this is pictures from where construction sites where these bars are exposed to the sunlight for a long period of time, months or even weeks at least. So all these will get exposed to the sunlight, and sunlight has UV radiation, and that will actually make this epoxy crack. Okay, that will crack this epoxy coating, and these cracks are not something which you can really see with your naked eyes until it is severely corroded. So I am going to show you some more cases where these bars are exposed, and you can see that there is a lot of these brown lines, brown things which you see on these bars. You see here, it's all very severely damaged, but they are unfortunately being used in our construction. So as a technology, epoxy coating is very good, but it is not being used in a proper manner in our construction site, and most of the sites. I am yet to see a construction site which is using good quality epoxy coating or epoxy coated rebars. So, it is very high time that we really worry about quality of these structures, okay, and the durability. They will start corroding very fast. Now, this is what happens. You can see I have been talking about this, they are getting cracked because of exposure to sunlight, right. So, in some lab experiments we saw that, in very few day 10, like, even if you really expose it to sunlight within a month, you will have a lot of cracking on the epoxy. So, this is also a microscopic image or a micrograph which shows that initially there is no cracking, and then after some time you will have a lot of cracks on the, you can see this lot of cracks on this epoxy coating. So, this green color coating which you see, even though you may not see the cracks with your naked eyes, when you look through microscope, you will see that there is a lot of cracks on such rebars, on such coatings when it is exposed to sunlight for a couple of weeks. So, we must, if we are going to use, you must ensure that these bars are handled like babies. They should be protected from sunlight and they should be protected from other abrasive actions. You can't walk on that, you cannot park vehicles on that. So, lot of care has to be taken when we use epoxy coated rebars. And so, what is that corrosion mechanism? Okay, how they corrode. So, this is some experiments which we did in our lab itself. You can see here by Dr. Deepak Kamte. You can see here this some of the scratches forms or becomes anode, whereas the other scratches become cathode. So, in corrosion reaction, there is an anode and a cathode, like in the battery you have an anode and a cathode, right. So, anode is the location where it corrodes and the cathodes are the locations on the bar where it helps to corrode, okay. So, what you need, the point which you have to understand today is that if you use this coated rebar, non-metallically coated rebar, there could be possibility of scratches or cracks on those epoxy coating which may or may not be visible with your naked eyes, and some of those cracks or scratches will start corroding while others will help the other scratches to corrode, okay. So, there is and the point here is this is going to happen even without sufficient chlorides. So, it is more dangerous to use this kind of rebars or damaged epoxy coated bars if you have, it is more dangerous to use damaged epoxy coated steel bar than an uncoated steel. So, look at these two pictures, what is really happening. If you have a vehicle like in a crack like this, what will happen? If it corrodes, it will corrode right at that crack alone, right, and that concentration will be high when you have a localized corrosion. So, similar to the picture or shown on the right side, where you have that green is the epoxy coating and the red portion is the corrosion products, and so you have a localized corrosion. So, the cross section of the rebar, the remaining area available will be very significantly affected. So, if you have a rebar like this, it will corrode something like this, okay. So, you have a localized corrosion attack. So, if this is the rebar, this is the rebar. So, you have a localized corrosion attack, and so the capacity of the steel is going to be reduced significantly locally. Okay, so some tips is that there are straight and bend rebars, but you should bend the bar before you apply the epoxy coating, and also check for holidays, scratches or cracks, and don't expose them to sunlight, and multiple layers of epoxy coating is possible, and definitely make sure that in your documents you write fusion bonded epoxy coating rather than just epoxy coating. Okay. If you don't do things properly, this is something what is going to happen. This is a picture from a bridge which is about 5-year-old in in Florida, and where they found that in 5 years itself you see how much corrosion is there. So, in fact, there are many places abroad where they have banned the use of epoxy coated rebars, especially in the developed countries, but unfortunately in our country we are still using a lot of these rebars. So, I say that we are not ready to use these bars because we do not have that much quality concern at our construction sites. So, message here is we should not use these bars unless we can ensure that these bars are taken care like babies. Okay, and babies we make sure that when we go out in sun they will be protected and we handle them very carefully, like that. These rebars also need that baby like treatment, otherwise they will not perform, they will not have any corrosion resistance, and in fact their corrosion resistance is going to be poorer than an uncoated reinforcement. So, you don't waste money, because this kind of coated rebars cost about 20 to 30% more money, and if you do that and you don't get the return, then it is of no use, no. So, another type of coating is cement polymer composite or CPC coated rebar. So, you can see there are all again one here is a cleaned surface of the rebar, and then you have a polymer a primer coating, and then on top you have a seal coating. So, it is a double layer system. Okay. Now, how does this one the rust free, or you have to clean the steel surface? We call it sandblasting. What is sandblasting? We take sand and spray the sand onto the steel surface. At construction sites you can see these things happening. You take the sand and spray it at high speed, very fine sand, and that will clean the steel surface. Okay, if there is any loose particles present or some rust is present, it will clean up all that. So, you get a very clean surface for the item number 2, which is the primer coat, to get bonded with the steel. And on top of the primer coat you apply the seal coat. Then we get this, but all this is done mostly at the construction site itself. Now, you can imagine how difficult it is to keep a steel surface so clean, So, because of that, and also at the site you may not apply this coating on all places, etc. So, because of that there is a lot of challenges in maintaining quality of these bars. Okay. So, now, so what does it do? What is the protection mechanism? Is this provides an alkaline environment to the steel, because this coat, the material itself which is used, it has cement mix in there. Okay, so it provides a better alkaline environment than the epoxy coated rebar which we talked about. Okay, so because of the alkaline environment, formation of passive film is possible, which is not, or a protective film or the oxide layer of the steel is possible, and also it eliminates direct physical contact between the steel and the concrete, and also there is a reduction. So, it is like a physical barrier, again you have a barrier effect, and but at the same time there is a little bit passive film formation is possible. However, if the item number 1, which is the clean surface, if that is not properly ensured, then the performance is not going to be as you expect. And also this is a picture from one of the bridge site, where you can see this kind of coating is applied, but there is a lot of places. I have put this red rectangles here in the zoomed in photograph, where you can very clearly see that that joints or the intersection between the vertical and horizontal bars are not at all painted. Okay, so when you have these discontinuities in the coating, okay, when you have discontinuities in the coating, you will again there is a possibility of battery to be formed, or corrosion cell can be formed. So, you are actually creating a more vulnerable scenario by inadequately applying the coating. So, any coating, for in a general principle for you to understand, any coating which you provide on a metal surface, it is always better to provide a good coating. If you do not provide a good coating, it is worse than providing no coating. So, if you are providing a coating, make sure it is of good quality, otherwise it is better not to do anything, just leave it uncoated. At least you will not have the concentrated corrosion. When you have the coating with damage, scratches, etc., or inadequate coating like this, what will happen is you will have a lot of localized corrosion, under film corrosion will happen. Localized crevice or under film corrosion will happen. If there is no coating, then there is no possibility of under film or crevice corrosions. Okay. So, Message is, it's more dangerous to use poorly coated steel than using conventional uncoated steel. So, do coating if you are able to do a proper coating, otherwise don't use it. Okay.